Hello everyone and welcome to Algebra 2, section 4.9. Today we're going to be modeling with polynomial functions. So first of all, you need 2 points to write the equation of a line. If you only have 1 point, you could draw so many different lines through it. But as soon as you have 2 points, there's only one way to draw that line. Similarly, if you have just 2 points and you were trying to draw a parabola, there's so many different parabolas that you could draw through those 2 points. But as soon as you have 3 points, then your parabola becomes set, and there's only one way to draw it. To do a cubic function, can you guess? Of course, you need 4 points to write the equation of a cubic function, and that's what we're going to do today. So they did give us 4 points. But what's most important is that they gave us the zeros. So once you have the zeros, you know the factors. If one of the zeros is x minus 2 or is negative 2, then x plus 2 is one of the factors. We have another 0 at 1, so x minus 1 must be one of the factors. And we have another 0 at 3, so x minus 3 must be one of the factors. You may remember doing this with quadratics. So the only thing we don't know is how steep it is. Now, because it passes through this 0, 3, we have a sense of it, but we need an actual value. We need this a value right here. So I'm going to write y is equal to a times x plus 2 times x minus 1 times x minus 3. And then I'm going to use that point to plug it into this equation. So 3 is equal to a times 0 plus 2 times 0 minus 1 times 0 minus 3. A times 2 times negative 1 times negative 3 is positive 6. So I divide both sides by 6, and I get 1/2. And now I can write my final answer. Y is equal to 1/2 x plus 2. And the order of these 3 factors does not matter. So if you understood this back when we did this for quadratics, then today is going to be a really easy day for you. In case you're already ready to go, I'm going to write the answer to this next one so that you could really just try these on your own. And then on the next page, here are the next 2. So I will, of course, go back and do them for you. So on this one, again, they've given us the zeros, and I use that to write my original equation. But I don't know how steep or shallow it's going to be. So x plus 4, x minus 1, and x minus 3. But they gave us this extra point, and I'm going to plug that in for x and y in order to figure out what a is. 0 plus 4, 0 minus 1, 0 minus 3. Multiplying those together, I get 12. So 12a, I divide both sides by 12, and I get negative 1/2. So my final answer is y is equal to negative 1/2, and you are not required to multiply this out. You can just write it, leave it in factored form, which is actually the most informative way to write something. If it was a big, long polynomial, I wouldn't have any idea how to graph it. But this polynomial, I can graph right away. I can find its y-intercept by letting x be 0, which of course we already know is negative 6. And I know that it ends down because it's negative, and sure enough, it did end down. And I know that it is not quite as steep, it has a 1/2 as a basic cubic function. All right, let's do the next 2. Make sure you got this. Y is equal to a times x plus 6 times x plus 3 times x minus 3. I'm using my zeros to write the factors. And just to go over again why that works, because if x is -6, then this factor will be 0. And if this factor is 0, it doesn't matter what the other factors are. The whole thing is going to be 0. So whenever they tell you one of the zeros, and they've told you 3 of them, then you also know a factor. The zeros and the factors are intricately related. So now I take my known point, and I'm going to plug it in. So -9 is equal to a times, not x, now we can plug in our 0. 0 plus 6 times 0 plus 3 times 0 minus 3. -9 is equal to, so this is -9 times 6 is 54a. It is negative. So I divide both sides by -54. And I get a is equal to positive 1/6. And I have a great way to double check. That means it should end up. So a should be positive, and it is. So I feel really good about that answer. I'm just going to go ahead and box this. It's silly to rewrite it because all we were missing was the a. And the last one, y is equal to, oh, did you catch this? It's a bounce. So don't forget that a bounce means that that factor has to be repeated. So x plus 4 squared. I plug in my known point, which this time they did not give me the y-intercept. So I plug in 1 for y. Oh, I didn't write my a. A, kind of squeezed it in there. A times -5 plus 6 times -5 plus 4 squared. So this is -1, but when you square it, it's 1. And this is 1. Everything's 1. And a does come out to be 1, which is why you don't see it in the answer. It's not required that you write a 1. But if you do write it, it's not wrong. On this next page, you can go ahead and try these. These are the same, except they didn't actually make the picture for you. But you should still be able to tell which ones are the x-intercepts and which ones are the y-intercepts based on the zeros. So remember that an x-intercept always has a y-coordinate of 0. So these are your x-intercepts, which means these are your factors. Y is equal to a times x plus 4. Oh, which I just realized when I wrote up those answers. So somebody was trying to do that problem. That's not what I got. There we go. X plus 4 times x minus 2 times x minus 5. And then this is the other point they gave you. It happens to be the y-intercept, but as we learned from this last problem, it can be any point. But this is just nice and easy to plug in. So remember that the y is the 10. I don't know a, and I'm plugging in 0 for all the x's. And 4 times -2 is -8, times -5 is 40, but I'm going to put it in front of the a. Divide both sides by 40, and I get a is equal to 1/4. Oh, I was about to box that, but that's not actually the answer. That's just the a, and then the final answer is writing the cubic function with the a filled in. Okay, there's only one left of these to try on your own. If you still haven't turned off this video and tried it on your own, I recommend you do so now. Let's find our x-intercepts. The x-intercepts are what help us get the factors. So I have x plus 1 times x minus 2 times x minus 3, but I don't know what a is. So there's a lot of different graphs that could go through -1, 2, and 3. I could draw all kinds of things. I could draw this, right? But then I see it passes through 0, -12, which mine doesn't. So that's how you're going to know whether or not you've done it correctly, is that your a should come out to be negative because I know that it passes through 0, -12. So let's go ahead and plug that in. -12 is equal to a times 0 plus 1 times 0 minus 2, 0 minus 3. -12 is equal to 6a. A is equal to -2, which is how we arrived at this answer. And I was expecting a to be negative. So you should probably on a quiz or a test make a super fast sketch of the 3 points just so you can check to see if your A sounds right. So I don't know if you remember this, but we learned earlier in the year about something called finite differences. So what that means is if you're making a table of values, and I let x be 0, 1, 2, 3, and then I find y is -1, 1, 3, 5. If you look at these, this goes up by 2 every single time the x goes up by 1. That's a way that you can know that the function is linear. Okay, which it is. It's x to the first power. So this goes up by the exact same amount every single time. For a parabola, it does something similar. Again, in order to actually compare it, I need x to go up by the same number each time. So I have to plug these numbers in. When I plug in a 0, that one's nice and easy. -1. When I plug in a 1, 1 plus 3 minus 1 is 3. When I plug in a 2, 4 plus 6 minus 1 is 9. When I plug in a 3, 9 plus 9 minus 1 is 17. And when I plug in a 4, 16 plus 12 minus 1 is 27. So I go to look for my finite differences, and I see that I have to add 4 to get from one number to the next. But then I have to add 6. And then I have to add 8. And then I have to add 10. So this tells me that it is not linear, which of course I knew. I can see the square. But for a parabola, it should work on the second, because the exponent is a 2, on the second branch. So now the difference between these is 2 and 2 and 2. It is pretty cool how that works. So of course, what are we going to do? We're going to do that for cubic functions. So your book makes their tables sideways. Again, you do have to check to make sure that x is going up by the same amount each time, or this won't work. So I'm going to go up by 3, up by 6, up by 10, up by 15, up by 21, and up by, what is that, 28. And of course, so it's not linear. So I do it again, up by 3, up by 4, up by 5, up by 6, up by 7, not quadratic. +1, +1, +1, +1. So since it's on the third set of loops, it is cubic. And that's pretty cool. Of course, what would be an easier way to do this problem? You could do a regression. You could put these into list 1 and list 2 and let your calculator do a cubic regression. And then you could actually find its value. And you could graph it and see if it looked cubic. So that's what we're going to do now, because the truth is, as cool as that is, finite differences rarely work with real life data. It might be close, but they're not necessarily perfect numbers. So we can turn to technology to create an equation that models the given data. For each of the following, enter the data into your calculator, create a graph of the data, then perform a regression to determine the equation that best fits the data. So we're going to switch to our graphing calculator as soon as I read this. The table shows the population Y of bacteria after X hours. Find a polynomial model for the data for the first 4.5 hours. Use the model to estimate the population level of bacteria in thousands after 1 day. So let's do that on our calculator. So we've done the regression several times this year, but I am going to go slow at first to make sure that everybody remembers how to do it. So first you want to enter the data in. So it's a statistic. So we're going to hit the stat button and we're going to edit. So I hit enter. Now I already have things in there from the last time we did this. So I'm going to go up using my arrow key to list 1 and then hit clear enter. I'm going to go over to list 2, go up to the actual L2 and hit clear enter. And now I'm going to enter my list 1, which is 0.5. You don't need to do the 0. It'll do it automatically. 1, 2.5, 3, 4, and 4.5. You can use your arrow key to go over to the next list and it'll start right at the top for you. 5.125, 6, 20.625, 32, 69, and 96.125. So now I'm going to make a graph of my data. Now, the thing you need to know is you're going to have to fix this window, which right now is probably just going from -10 to 10 in both directions. But I really only want to see from 0 to maybe 5. But I need my y values to go from 0 up to about 100. So let's go to our window and say 0 to 5, or you can go higher than 5 if you want to. And the y needs to go from 0 to 100. But making a graph, this always looks to make the graph from the y is equal to, and we don't know the equation yet. What we're going to do is plot it, which is in the same basic area, but it's right above it. So second y is equal to. So let's plot our data. All you have to do is hit enter, and now it'll give you a toggle between on and off. So hit enter again, and that'll turn your graph on. Right now it's making dots. It's using list 1 and list 2. You're welcome to change the mark if you don't want yours to be squares, and you're welcome to change your color. So I hit graph again. This time, oh, I accidentally hit second graph. So just graph, and there it is. Ooh, it definitely is not that you look at it and say, oh, that's definitely cubic. It could be exponential. It could be parabolic. We really don't know. The data isn't clear. So what we're going to do is we're going to run our regression. So I go back to my statistics and I want to do a calculation. I'm going to do both the quadratic regression and the cubic, although you know it's going to be cubic because we're in the chapter on polynomials. We've already done the quadratics. But let's go to 5. Quadratic regression is saying, do you want to use list 1 and list 2? You're like, yeah, that's good. Enter, 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 calculate. And there it goes. And it gave me a pretty high accuracy, 0.998. So I'm trying to decide if I want to write that down or not. I don't think I'm actually going to write it down. I'm just going to do the next one. So I go back to stat, over to calculate, and this time I'm going to do a cubic regression and see how accurate this one is. List 1, list 2, we'll just go down to calculate. Okay, now this is sometimes confusing to kids, but this one, this 2.05 e to the negative 11 is your calculator's way of writing scientific notation. It actually means that it's times 10 to the negative 11, which means you're going to take this decimal point and move it over 11 times, which is be 0.0000000000000, whatever, 205. In other words, it's pretty much 0, and C is pretty much 0, and then D is 5. But look at the R square value. This is showing that it's perfectly correlated to a cubic. So even though the other one was pretty good, 0.998. This one is 1. So let's type this in. We're going to call those 0. So I go to y is equal to, and I say x cubed, and then 0x squared, 0x plus 5, and I'm going to hit graph. And look at that. It literally goes exactly through it. So if you wanted to see more of the cubic shape, then you could just change your window to -5. Oop, I just used 0.5. -5 to 5, and then maybe -100 to 100. But our data only fell in this area. But if you want to see the whole graph, it is a cubic function. So I transfer onto my paper the equation that I just found on my calculator, which is y is equal to x cubed plus 5. Remember, the x stands for how many hours for the bacteria, and then the y actually shows the number of bacteria in thousands. So the next part of the question says, use the model to estimate the population level of the bacteria in thousands after 1 day, which, because we're working in hours, we'll have to change that to 24 hours. So I was going to use y, but you know what? This is where function notation is really great, because then I can make it clear that I'm plugging in 24 into my function. So 24 cubed plus 5. I get out my calculator, and that comes out to be 13829. So of course, some people are going to stop here, and you're going to miss the last point. This tells you the population of the bacteria in thousands. So it's 13,829 thousands, which of course that's a little silly to write 13,000 thousands. So instead, we would actually make it in thousands, which of course comes out to be 13,829,000 bacteria. Just like there really weren't 5.125 bacteria, there were 5,125. There were 6,000 after 1 hour. So after 24 hours, it is equal to this many bacteria. So this is a little bit of a struggle for people doing this concept when it's in thousands. The next one is even harder. The table shows the value y in thousands of dollars of a signed autograph of a MVP football player, where X represents the number of years since 2000. So if it's been 1 year since 2000, in other words, if it's 2001, then the value of the autograph is $6,000. But if it's been 5 years since 2001, it's 2005, then it's 1,246, but then it's in thousands, so it's actually $1 million, 246,000. So hopefully you can see that. Find a polynomial model for the data for the first 5 years. So again, we're going to go back to our calculator and enter this data in. So I already entered my data in, and now I want to do the regression. So I'm going to go to Stat, Calculate, and again, I'm going to start with the quadratic regression and see what I get from that. I'm looking at the correlation factor, which is very high, 0.992. And then I'm going to go to, I'm going to do it again, Stat, Calc, and cubic regression. See what I get. Sorry, my calculator is a little slow sometimes. Ooh, 0.999. Okay, so it's definitely cubic, not quadratic. Or could it be quartic? So I'm going to do it one more time. Stat, calculate. I'm going to go down to my quartic regression, which would mean it would be to the 4th power. I hit enter, 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 enter. Sorry. And I get a correlation value of 1. So that's what it is. And again, I look at this and I say this e to the negative 10, that means it's pretty much 0 because it's 0.00000000003. So it's tiny. But I do have a d of 2 and an e of 6 that I need to record. So when I go to my y is equal to, I can just hit clear. It's going to be 2x to the 4th minus 2x plus 6. Now, before I hit graph, I can hit graph. So I see something, but I only see 2 of my data points. And why is that? Again, because of the window. This data goes from 0 to 5. I don't need to change that. But my y min is going to, again, there's no negative dollars of the value of these baseball cards, but it goes all the way up to 1,246 in thousands. But the reason they do that is so you don't actually have your calculator go up to a million. So 1, 2, I was going to do 4, 6, but that's silly. Let's just do 1,500 so you can see it clearly. And you don't have to go to the stat plot again. It'll automatically do that if your plots are still on. And of course, you can see that it's practically perfect. So the question is, use the model to estimate what year the autograph will be valued at $5 million. This is tricky because you actually want to know when it's going to be equal to $5,000 because 5,000 on your graph represents $5 million. So because this is it's being measured in thousands. So 5,000 is actually 5 million. Remember, this is going to make a horizontal line straight across. And I don't see it. Why don't I see it? Because remember, my window only went up to 1,500. Now I need my window to go up to at least 5,000. But I'm going to make it 6,000 to make sure I can see it clearly. And I'm probably going to have to go further out in the x direction too. I don't know how many years it'll take, but let's just say it takes 10 years. If I still can't see it, then I'll do more. So I hit graph, and there it is. So look at that. This was the value after 1 year, 2 year, 3 year, 4 year, 5 years, and it just kept taking off. It follows a quartic graph. So what year is that? I can use my intersect button, number 5. I hit first curve. They're saying the first curve, is it this one, this 2x to the 4th? And you're like, yep. So you hit enter. And it says second curve, is your second curve this one, this red one at y2 is equal to 5,000? You say, yep. And then it asks you to make a guess. You don't have to guess. In calculus, I'll tell you why you guess. And the intersection is 7.07 and 5,000. But remember, the 5,000 actually means 5 million because it's being measured in thousands. And the 7.07 actually means years since the year 2000. So this actually means 2007. All right, that is it, not only for section 4.9, but it is it for chapter 4. Have a great day.